try. Also, I'm Alphonse Hu, and I'm currently a software engineer in Synology Taiwan. And I have been working since 2021 November. My first project is in the uh, work as a backend engineer in the C2 cloud. And the C2 cloud is a hybrid cloud solution which combines the performance of the Synology NAS or network attached storage local file system with the scalability and the privacy of our own cloud storage, or we have our own cloud object storage. So in the first team, I developed some gRPC APIs to support the file sharing system with the access control list because the file sharing method is our main feature that can mimic the file sharing like those in the Google Drive where you can right click on any file you want to share with someone. So my job is to write some Golang in the backend to query the access control list for the permission control, and I also deploy the microservices for the whole system such that we can um, convert some RESTful API from the front end and convert to the back end, which is gRPC for more efficient file access. And that is my first project starting from November 2021 to October 2022. And starting from November 2022 to present is the scale out file system. The scale out file system, which is quite different from the traditional file system like ext4 or NTFS or Synology, which uses BTRFS. The scale file system is mainly the CFS, where it is built on a distributed environment, and once you write some file or access some file doing the write operation on one node, it will automatically replicate what you have write into it into other nodes, which provides the high availability and scalability. Now I am in charge of the two projects in my new team. The first one is log system backup. Because our log system is a master slave architecture where the master node can collect all of the slaves system log, including the log of the master node its own, and the log system on the master node can show the timely information of what's happening on all the node. However, due to our high availability design that somehow in some time maybe the master node will somehow malfunctions and it need to fail over to the other agent node or say the slave node. So in this time we have to back up all the log from the original master node and can handle the log recovering during the cluster failover such that we can view the original log at the new elected master node, which is my first project. The second project is the file protocol load balance because there are lots of the file inquiry in our scale out file system, and we don't want all of the file protocol or the file access path to be served only by one node. We want to distribute the load balance into different nodes. For example, you want your Samba protocol access the path A to be served by node A, and your NFS protocol access the path B accessed by to be served by the node B. In this case, your file access can be separated into lots of the node, which can alleviate the system overhead. So yeah, this basically sums up my experiences, and you can see from my resume the blue letter on the work experience sums up the tech stack I used.
Yeah, thanks for your sort of introductions, and that's really detail oriented, and I really know what you were doing. So let me just type something. Okay. Okay. So thanks for that. So before that, I have a couple questions for you. Let me just start from the bottom. Is that okay for you?
From what?
That's just from the bottom,
From the
bottom of the skills.
Okay,
That's
okay.
we supposedly read the same resume PDF, right?
Yeah. Skills. You mean programming language, frameworks, tools, and natural languages at that page.
Sorry, I was thinking of it a little bit upper. Let's just take a look at some selected projects. That's key because I'm kind of interested in a couple of them. So
Selected projects. Okay, selected
yes,
projects.
selected project. Okay. So can you briefly introduce the multiplayer cooperative VR game? First, I want to know why would you do that, and what's the scenario for you to doing this?
Okay, the multiplayer corporate VR game is my graduation project, and at that time, I was quite fascinated by the game design during my senior year. And traditionally, when someone wears a VR headset, you usually only sees your yourself playing your own game, and our game is like a parkour game called something like Temple Run. And however, we want to extend this feeling because we don't want only one people to enjoy the parkour game, and we want to have a cooperated version of the parkour. So we uses the multiplayer in the Unity, and I am in charge of the networking foundation of that part. I can let 2 to 3 players to join into our game at the same time. And at time, the challenge is because there are lots of the communications between each of the VR headset, and you cannot rely on the poor Wi-Fi or the slow local area network for the communication, right? Because the VR is high in the video resolution. So I came up an idea is that how about we just use the internet working, because there are lots of the RJ45 in each of the computer, and actually I found that RJ45 or the CAT cable in of the networking can actually be directly plugged into the other's computer's same port. So in this scenario, you are not directly put your network traffic through your something like ADSL or the switch on the. However, you just directly pass through your network traffic from one computer to the another. So in our settings, we support up to 3 players to join into the same playing room, and so we connected 3 computers, and they are connected by the RJ45 internet cable. So this is maybe this can sum up my experience of how important to be a network engineer in our multiplayer cooperative VR game. Yes.
Okay. So thank you for your introducing. So I got a couple questions for you. So you just mentioned that you had the keyword RJ45. Can you introduce me about explain a bit about that? And also you mentioned that most of the development for VR game they're just mainly for solo player. And how do you implement it to make this to be a multiplayer game? That's my second question. And my last questions will be, what if the user will, participated in out of order? Like, how do you design such system to make the game to be played in um, multiplayer mode?
Sorry, what's your
Yeah.
first question?
My first question is, what is RJ45?
Okay.
Because you keep mentioning the things, but clearly I don't, because I'm not there, so I don't know what that is.
Okay.
So yeah.
And
Thank you.
Okay. So I answer the first question. The RJ45 is standardized internet socket. Is used for the wired networking. So when you connect your RJ45 through a cable to ADSL, you can connect to your internet from the external, or you can connect your RJ45 to the other computer under the same area network. This forms an intranet.
Okay.
Okay, and your second question is, can you briefly explain again your second question?
I okay. So my third. Let me just let's just move on to the third questions. My third questions would be, how do you design this to be a multiplayer VR game? Because the multiplayer is sorry, I should put it in this way. So the multiplayer game that you design is you that the users is to participate in whatever they want, or they have to start together.
Oh, actually, there is a function in the Unity system that natively allows the player to be joined via the local area network, and it works like it somehow works like each of the players should be they are registered by their IP or say MAC address, and they will be identified by a unique UUID. So they can be identified like they can be uniquely identified by ID generated by your hardware information. So you can ensure that what are the players you can control in your gaming room. But our difficulty does not lie on how do we let lots of the players join to the same room, but they have to render the same videos at the same time, and the video is quite high in resolution, and there is only one computer installed with our asset. You know the asset? The asset is the scene or how the character. So it is a bit like a master-slave architecture where the master can streaming the master provides the detailed data of how the game looks like and how the character looks like, and while the slave computer, the other two computers, just perform as the receiver. So they have to be communicated through the local area network to make it faster.
Cool. So you mentioned that there is a master slave architectures. So how do you implement the sharing part? Like you mentioned that the master will send information to the slave, and the slave will just play the information from the master. And how does the slave to accept such information? What kind of technology that you've been using here?
It's used by socket programming because it is formed in a local area network or intranet. So do you know the ARP protocol where you can pin say you have the master slave may have the IP that 192.0.0.1, and your slave will be assigned into 192.0.0.2 and 192.0.0.3. Since in your master you understand how where the slave's IP is, so you can send the required packet to your slave, while the slave can send back their ACK message to the master, because they are bidirectional, and the either node or whether the master or the slave can all know the others via the local network. So this confirms up how we send the data and receive the data between our master and slave computer.
Okay, I see. Yeah, I think this is very nice. And also have interested in your third one, CPU parallel accelerations for OpenSlide. And it looks like this one is a little bit related to your publications, right?
Yes.
Yeah, so can you briefly introduce about these two?
Okay, this is actually in my graduate thesis. And my graduate thesis mainly lies on how can we optimize the image processing, or say image loading part for the digital pathology pipeline. The digital pathology pipeline is we want to analyze the digital slice of a sick people through the Python computer vision toolkit, and want to know that which of the part of the patient should be treated or can somehow be malfunctions. However, the wall slide image, or say the pathological wall slide images, is great in pixels, usually in billions pixels. So to train a lot of the data based on the wall slide images, it requires a specialized data loading tool called OpenSlide to extract and decompress the special formed data called WSI image. So the WSI image is usually very big, and this will take up lots of the time for the further pipeline, because the further pipeline is usually quite fast, because there can be parallel training by lots of the NVIDIA GPU. However, the traditional OpenSlide only load image one thread at a time, and if you load multiple of the image, the memory will be cleared and reallocated again. So this is not only computing inefficient, but also the memory inefficient. So in this design, I tried to use lots of the profilers such as Intel VTune, GPerf tool, Google Performance Tuning tool, and Perf to find out where does the performance bottleneck lies. And it turns out that during the image decompression, the OpenSlide only uses a single thread. So I tried to parallel slice it to the multi-thread systems. So you can see from my resume, it can run up to 25 times faster in a 30-core machine. And it is not only faster, but we have to also care about the accuracy as well, because it is used for medical training, so it cannot generate too much error. So I use the structural similarity index to analyze all the image generated by the parallel method and compare to the serial one, which the structural similarity is nearly 100. So this sums up my CPU parallel acceleration of the OpenSlide.
Yeah, good. Thanks. Thanks for letting me know what that is. So I got a couple questions for this. So So you mentioned that you're using some tools to analyze, help you to analyze the problem. Like you mentioned that this problem gonna take very long to execute. And how do you found how what's approach that you took to found that the bottleneck is actually the image the deserializer?
Okay.
The yeah. How do you found it? Because you mentioned that you're using some tools, but the whole image processing will be a lot of process. So how do you found that is exactly the bottleneck?
Okay,
How do you confirm that?
to deeper dive that, the OpenSlide is a Python library. However, it actually loads the C library, shared library compiled by the C style OpenSlide. So I first used the gperf tool to profile my Python code, which is simply just an OpenSlide open and load image. And I found that this Python tool is actually loaded the custom share object. So I run the C version of it because Intel VTune runs better and can runs more natively on the C version. So I then use the Intel VTune to found that it is somehow in the image decoding function or the image decoding kernel, it is very slow. And when I click the CPU usage of that function, because Intel VTune can be, it is a profiler from the GUI tool and also provide a data visualization of each of the functions from top to down and how is the CPU used. So then I found the image decoding part take about the 96% of the word time, and to my surprising, it only used one single thread. So I think that I can write my own image decoding part. So I write my own parallel version of the image decoding part and compiled into a own shared library. So when the Python is running, I don't want it to load the system predefined share library like in USR local lib something.so, but I want the Python to use my own share library. And to use this method, I can use C type for Python has a library called C type, and it supports the passing the memory between the Python and the C code, which can make the code design or working for the high performance Python C style code. And
Right.
apart from that, I also pre-allocated the memory in Python because not only did I need to load one image, but I have to load maybe tens of hundreds of images at the same time. So if I have to on demand allocate it and free the memory for each image, then the overhead will be very big. So to me, I pre-allocated a very large image memory pool and passes to underlying C code. So each time the C loads the image, it can reuse the same shared library. It just overwrite the existing data, so it will be fine for every image. And till the last image, I can finally free without any worry. And this also boosts up the I/O bound.
Yeah. Okay. Cool. I think you do mention a lot. So because due to the time issue, so I gotta ask you one last question. So according to this topic, so you mentioned that you tried it on write it in C code, and can you just briefly tell me where did you test in your what's the testing machine that you are using, and did you do a customized improvement on your just according to what's machine that you are using? Like say for example, once you are you will
What's
be
my
using Intel in some version.
testing
Sorry?
environment?
Oh, oh yeah, yeah. Testing environment. Where do you use it? What kind of machine that you are using for this?
Okay, sure.
Yeah, and also, do you do customized optimizations for each, for this? Yeah, kind of question, kind of curiosity. Yeah.
I'm actually testing on the NCHC Taiwan National Center of High Performance Computing. In Chinese is 国网中心, and it provides a supercomputer for each. It is a darker environment and it provides a lot of the tiering. So I'm using the 32 core plane because I want to test up for each combination in single core, 2 core, 4 core, 8 core, 16 core, and 30 core to
Cool.
see how much performance gain I can do in the various core combinations under my project.
Okay, I see. Thanks. Thanks for that. I think that's really helpful, and you explained very well. So let's just move on to the work experience for a bit, because I got around 15 minutes, so I want to make this one a bit solid. So I see you have two interns, one for MediaTek, one for the Candace. So I think each of these were related to um, more low-level things. But why do you choose to do more back-end things when you go to Synology? I mean, just out of curiosity, if you don't want to answer, just
yeah,
we can
because
just move on to our next. Yeah.
I actually in NCTU and because MediaTek is just a very convenient internship for me because I don't need to rent houses or I have and the MediaTek is quite close to our own campus, so I chose MediaTek as my first 第一志愿 yeah to my first priority for my summer internship in 2018, and also my internship is focused on image processing, and because at that semester I just finished my image processing course, so I think it will be more relevant for me to choose. And for cadence design systems, at that time the cadence design system is maybe my second priority because I just failed my first priorities interview, so I choose my second priority. Yeah.
Okay.
But
yeah.
I have more experience after the graduation because I focus more on performance or networking systems, so that's why I choose to be a backend engineer in Synology in my first full-time job.
Okay, thank you. So right now I got a couple of questions related to Synology. Even though you just do introduce me a lot, but unfortunately, when I was listening, I kind of zoom out because sometimes it's too detail oriented. So still good to understand what you were doing. So I want to ask a couple of questions for your two teams. So my first question is according to your first team in storage gateway team. So can you just tell me what's the toughest project that you've been done in this team, and why is it hard, and how do you solve this? Yeah.
Okay, the toughest part in my first team is because we use there is inode in Linux system, right, where you keep tracking of the file by an integer, and when we are going to share a file to another users, we are actually keep tracking of our sharing data based on inode. So for example, you share this document and this document shares to John. So we will insert to table something like 1 and John to symbolize their relationship. However, the Synology NAS can be mounted into Windows via the SMB protocol. And during the SMB protocol, you can write a Microsoft Office file. It is not limited to maybe say Word or PPT, but for all the Microsoft Office file, it has a strange behavior that when you save a file or write something to the file and you save it, it will naturally overwrite to the original file. It will create a temporary file and move your old data to your new temporary file and delete the old file. So in this scenario, this will cause our original sharing table to be wrong because, for example, you want to share the inode number 1 to John. However, maybe Tina mounted the file via SMB protocol to Windows, and Tina added it. So the inode will change, and John will not able to access the same file again. Yeah,
I know. Okay, so let me just using it another way to understand the problem. So because I kind of don't know what's the the user level using for the cases. I think you're explaining very well, but I just kind of don't understand how that actually works. So I can imagine that there is a word or Synology has on some word-like object, letting people to cooperate in over it. Is that right? So that's why you mentioned the Word, PowerPoint, maybe Excel.
Yeah,
because basically they are in Linux file system level. They are just inode. Is that right?
Because we use inode to track the word, and
okay.
And there is a behavior that the save will cause the inode to change. So your originally sharing link will be fail. So how we handle is that we need to capture how the Windows system code can be mapped to the Linux system code, and we capture the pattern and we map that pattern into a graph or a mathematical model. So we use a Linux system code, the combination of Linux system code, and keep track if the model or the pattern is matched. If the pattern is matched, then we have to update our sharing record, and thus to try to keep the sharing record will remain available even if the file inode is changed.
Okay, I see. Let's say if you have chances to modify the basic over this project, and you have the ability, you have the resources, you have the time. So what will you do from scratch?
You mean if I have encountered the same problem, is there any better way to do it if I can roll back even if I have to reconstruct my own database?
Sorry, I think my problem is more like because you basically tell me now that existing system is really bad. That's why you have to do really weird behavior or weird algorithm to detect which one is being changed.
Yeah.
Is that right?
Yes.
So if you have a chance to design the system, start over, which part of which part of the system that you will do the improvement, and what kind of the improvement that will be?
Okay, I cannot modify how the Microsoft Office works, so I will not use the inode to keep tracking of my sharing record. Maybe I will track of my sharing path and hash it, so I will have a unique hash number to share my file. And it will not be valid if the file name has changed, but it can be somehow to remain available. Sorry, I can use a hash of my file path to make a share link, and the share link will always be accessible if the file name is not changed. Yes, and maybe we can have a limitation that if the file name is changed, then we are not referencing to the same file, and it is by design, so it's fine.
Cool. That'd be great. Thanks for your explanations. And let's move on to our final one. Okay. So right now you're in your new team. So can you briefly introduce what does the team mainly focus on, and what does the team mainly do? What's the part of you is participating in? Like, what does your tech lead mainly assign you to do? Yeah, I think that's pretty much it.
Okay, my team. Your first question is, what's my team mainly focus on?
Yeah, and my second question is, I may like to change my second question because I would like to know the file protocol load balance. Just briefly introducing that one, that will be enough.
Okay, my team focus on the high performance file system. Unlike the single node of the NAS, which can serve the read by one machine at a time, in this scenario, we can separate our file into multiple machines and perform a parallel read. So to sum up, our team wants to build a supercomputer NAS, but mainly lies on the I/O throughput.
Okay, so can you explain a bit more about the I/O throughput? Okay. I think it's kind of related to what you've been done for the second one, right?
The I/O throughput can be measured at like how many megabytes of the second it can be transferred. So when it is only on a single node, it can be only read on a single instance at a time. But for a multiple node, they can be parallel read, just like a RAID, RAID 0 in your own systems. But the RAID 0 is very dangerous for a single node. But however, in the multi-node scenario, we actually read lots of the data from the redundant node. So it is not only very fast, but all of the nodes can be redundant back up to each other. So it guarantees the very fast read and the reliability.
I see. So can you describe how do you confirm that? If you don't know, that's okay. So did you know how does your team to decide to
measure
100%? Yeah, not measure, to confirm that the data is up to date, or they at least have some consensus over sort of data. And how did they do that? Do you know that?
Yeah, I didn't know a bit about that because it is.
It's okay. Just want to ask what kind of technology that you've been participating in.
Parity check, because when there is error in during the read, and we found an error, the parity is not identical with the expected one. So the redundant data for the backup node will try to fix the corrupted data and try to fix based on the parity code. So that's how we ensure the data is safely replicated to multi-node architecture.
Okay, thanks. And I think that's pretty much it for our first part. You want to take 5?
Take break?
Yeah.
Okay.
你要休息一下吗？
好啊。
我喝个水一下。
好。
喝个水一下。
拜拜。
You ready for the next challenge? This next challenge is a bit hard, so you can just take your time and try to try to understand how that works. Okay.
Okay.
Okay. So let me. Can you just give me 5 minutes? I just want to find a great graph for you. Okay. 1 second.
Okay. Regarding to system design.
Yeah, it's regarding system design. I won't take it very long because, for this part, we can definitely discuss it for a long time. But I don't think that will be necessary.
Because there is no standardized solution for the system design. Okay.
Yeah, there's no, specific things for that. Okay. So, before I jump into the next part, the couple of things I would like to let you know is, for the next part for the system design, we don't need to design a system. We just discuss a system. Is that okay for you?
Discuss what?
And we discuss the architecture.
Okay, discuss the
of a system.
Sure.
Yeah, and I'm just probably gonna ask you a couple questions, and it won't be hard, just to make sure that we can discuss it over it.
Okay.
Okay.
Good.
Okay. So if you're ready, we can just start it.
Yeah, I'm ready.
Okay. Let me check this out. Keep recording. Okay. So can you see my screen?
No. Yes.
1 second. So can you see? I don't know, probably this.
What one?
Like this, like, where I'm showing right here. Can you see this?
Orchestrating data pipeline. Which one?
Orchestrating things. Maybe this one. Can you see this graph?
Yeah. Spark, Docker, something.
Yeah, something like that. Okay, so let's move on to a little bit lower. Yeah, I did see one good, but it's gone. I don't know where it goes. Okay. So before we get into this, do you know anything about airflow or orchestration graph or some flow for the function running? Do you know anything about this?
Flight?
Do you know about airflow? Do you know about airflow?
Nothing. I know nothing about Apache airflow.
It's okay. It's okay. So let me just briefly introduce about airflow because I'm not familiar with it as well, but I can just briefly tell you, what it is. So can you see this graph here?
Yeah.
Yeah, this one. Okay. So let's just zoom in for a bit. So basically, when you writing a code, maybe for something like this. Sorry, this is a leak. Oh, not a leak code. Sorry.
Hey, can you use laser pointer? Do you have laser pointer? I can't see your cursor very clear.
Right now, can you see my cursor?
Yeah, it's bigger.
Okay, I was just using this because I don't know how to use a razor point. So that's 1 second. Let's imagine that. Okay, so let me just introduce what is airflow. So basically, airflow is, you can imagine there is a workflow. So what a workflow is there. You can imagine that as something like left here. This can be viewed as a workflow. It's basically a sequence of a function. You can imagine it as a function that works from top to the bottom. So, like, say for example, for this, you're gonna firstly we have to call an if this is do something, and this is if, and we do something else, and if we go to the else condition, we're gonna do a bunch of stuff. So that's the concept how this program works. Is that okay for you so far?
Yeah.
Okay, so picturing, you can separating each of these, abstracting into a small part. So for each of the small part, let's say for the middle for loop here, for each of the tree now, you're gonna Lisa will add something and will do something. So this can be viewed as a small thing, this so-called task. Okay. So you can, and the whole thing here is a workflow. So you can imagine the workflow is a combination of the interaction of some small task. That's makes it a workflow. Is that okay for you?
So my understanding is that Apache Airflow can orchestrate it. You can actually modularize or abstract lots of the independent or dependent. It doesn't matter. Independent or dependent small task, and you have multiple small tasks, and you use Apache Airflow to orchestrate them and make them want to operate it or go through what you want to do. Just like you write a code, but your code is now abstract into a higher level war module, maybe a Docker or maybe a binary tool. So you have to run binary tool one after one. You can use the Apache Airflow to manage it.
Correct. Okay. So that's the basic of the Airflow. So flight is something else, but it's a similar concept in Airflow. So if you writing this code, we don't see the decorators up here. So all you know is, we have if you read the WF2, the functions here, when you call this, it will just call a sequence for T1, T2, and T3, right? So basically for this in a workflow, in the workflow format, I'm sorry, I just keep using a wrong one. I guess, should be this. Yeah. If we're using the workflow format, it's gonna look just like task one and this. Can you see the cursor?
Yeah. So in your Python
first
code,
one, second one, third one. Yeah.
Your Python code, you have a what I say, decorator.
Yeah, decorator.
Of the workflow, and it tells the function to complete your function 3 before the other after the other 3 have been completed.
Yes, you're correct. This is a very good understanding about this. Yeah, so that's the basic of the workflow. So is that okay for you?
Okay.
So before I get into the problem, do you have anything to ask me?
So can I see that Python code again? You are providing me with your decorator.
Okay, let me just move on to here. Yeah.
You have T1, T2, T3. Is their order be guaranteed, or are they executed out of order, or are they executed in parallel? How do I know based on this Python code? Okay,
that's a good question. So your question is, how can I confirm that the execution result is, based on what I write, right?
Yeah.
Okay, so let me just get to you my recent results. So it's a similar one. So once you write in the way like that, the workflow will execute in exactly order that you are right. So let's say we have T1, T2, T3. So in Python work logic, firstly, we have to work T1, right? Then we have the output of the T1 to the T2 and so on and so forth.
Yeah, you pipe into the next one.
Yeah, so if we see a graph right here, the workflow will gonna look something like exactly like that.
Okay.
So we have a starting point, which is WF workflow WF3, but it's exactly the same code, but just different data. So we just starting it and T1, T2, T3, and that's it. Yeah.
Okay. No problem.
Do you have any other questions for this?
No.
Okay, so let's say let's just get a little bit deep dive into the architecture and let's discuss it. Okay.
Okay.
So as you can imagine that this is basically the whole structures, and the goal here today is I would like to discuss with you the part of just right here. Do you see how it was going here? Yeah.
Workflow management
The cursor?
flight API.
Yeah. Yeah. Only just discuss the flight API because for the rest of the part, I'm not that sure. But I can confirm how it's been doing right here.
So your cursor, you mean the publish new model version, that the block, or the flight API? Which block?
Yeah. For the bottom part.
Okay.
Like how does the management tool will interact with this? So in your mind, how do you think the workflow manage tool we're gonna through flight API to interact with this, based on the understanding that you have?
So you mean the flight API? Is the flight API? What's the relationship between the flight API and the airflow?
You can imagine that they do similar stuff. They always letting the program to form into a graph like that, and they have a starting point and go to each of the tasks based on the graph, and then done their execution.
So I can understand that the flight is tool service or something built on the Apache Airflow.
This part I can't answer you because I didn't take investigation over this one. So you can imagine that represents a similar idea.
Okay.
But it's not really important.
Okay, so it is a tool to ensure the correct workflow. Okay, sure.
Yeah. So my problem here today is based on the things that you have so far. Like there is a workflow, right? And let's just start from the basic one. Okay. So because the function looks something like that, is you can imagine each of the tasks can be changed into something else, right?
Yeah.
So let's say the task 2 to be, or this part, the middle part, that's changed to the training things, because this whole pipeline thing is mainly for the ML infra. So each of one of the tasks be replaced into a training operator is pretty normal.
Yes.
So
because training is also a pipeline.
Yeah, it's a pipeline. So what would you do? And what do you think is going to happen when couple of the one of the tasks has been it's off, or it's dead? What would the system supposed to do to support the whole system to keep alive every time, every single time? What do you think?
Okay, so you mean that, for example, we have task 1, 2, 3 connected in an order, and what if task 2 in the middle dies? What do we have to do to keep the system keep running?
Yes, and also keep the task 2 to to run the results correctly.
So are task 1, 2, 3 running on a cloud environment? Is task 1, 2, 3 something like a Docker pod or Docker pod?
Correct. Yeah.
Okay.
You can imagine this around Docker pod.
So my assumption is, if this is a Docker pod, so pod 1 for task 1 and pod 2 for 2, pod 3 for 3.
Yes.
So now pod 2 is died. And your question is, how do we solve this error?
Yeah. How do we what kind of thing that you expected to let the image that you just mentioned keep alive?
But you have to define what kind of error is in pod 2. For example, if your error is you don't have enough memory resource, or it is killed by the OON, maybe you have to enhance or increase the memory proportion of the pod 2's YML config to make it can be allocated for the more memory resources. And for the second one, if the pod 2 is died due to not too much CPU resources, maybe just like the memory one, you have to increase its CPU bandwidth. However, if the third one is maybe you have a network error, then it means that the pod may be died not due to resource, but it just died and cannot be respond. Then in this scenario, you have to change your configuration into the more replica. In this case, the second replica will try to rescue it, because Docker can have multiple replicas. Suppose one dies, the other one can take hand and relay our current work. And suppose there is a very, very critical one. And for the fourth one is maybe this version of the Docker, the code you deploy to that Docker does not satisfied. So in this scenario, we can roll back to the previous build. So this is the code error. And I think the fourth one is the most critical, because you have to manually roll back with the whole system and takes the longest time. So that sums up for my 4 kind of the solution for 4 different type causing the pod 2 to die.
Yeah, I think you answer it very perfectly. And what I actually, mainly want to ask you is, maybe, yeah, I think it's okay. So you mentioned that the system is built on Docker, right?
Yeah.
Or some other system. There's some other way to build it, but anyhow, they somehow virtualize the working environment and using an image to replace with that. So because each of the tasks is working in an image, so how do they actually pass the information from one task to one another? Another way to describe it is, how do they communicate it?
You mean how do they share? So for example, your question is, if the task 1 on the virtualized environment want to send the processed result into task 2 in the virtualized container 2, how can they communicate?
Right. So let's be more specific. Like, let's say we have task 1, right? So task 1 wants to assign the task 2 was result.
Okay.
Or in line 50. So how do they pass it? Because T1, T2 is supposed to be in
a totally different
image. Yes.
Okay.
So what kind of way to letting these two to be communicated? Yeah.
Okay, because this is in the virtualized environment, and can I assume that the pod 1, task 1 in the virtualized environment 1, or simply say pod 1, can be assigned a IP? Can I do this?
Yeah, you can assume that.
So the IP1 is assigned to pod 1, and the IP2 is assigned to pod 2. So I can serialize or packed or compressed what my result in pod 1 and send it via the socket program, a socket tunnel, or maybe I can use the gRPC for the interclass communication. I then serialize all the data I have finished in part 1, and the IP2 need to listen the port of in IP2. So I send from IP1 into port X of the IP2 on the part 2, and on the part 2 I have to listen on the port X for the incoming traffic from the part 1, and after I have the incoming traffic from the part 1, I can deserialize what I received and keep working on the processed result from the part 1.
Okay, that's fair. That's fair. And I think that you did answer this very clearly. So can you briefly introduce the gRPC a little
Okay.
bit?
The gRPC,
And
what's the benefit of it?
yes.
gRPC is a way to send data, and it mainly benefit is it serializes the data into a binary string, so it is much faster than just pass the uncompressed or the human readable JSON data. So it can be very suitable for the intercluster communication in our environment set, where we can put the data into a gRPC tunnel from part 1 to part 2, and the part 1 can register a method in part 2. So when part 1 use the RPC code in part 2, then it can set what the data the part 2 want, and it won't set other unnecessary information. And that's why the gRPC benefited.
Cool. Thanks for that. And let's go on to the final questions. So do you remember that the part that we have here?
A model publishing?
I would like to say the workflow management tool all the way down to the offline process. Do you remember this?
Yeah. Okay.
So based on the knowledge that you have in workflow, how would you implement? Let's say we just complicated each of the tasks to be, some PyTorch things and model evaluations and all the way down to model publishing. So, what do you, what do you think the potential issues right here? This is the last question because this is the last question. So if you don't know how to answer, it's okay.
So
this
can
is
you
open-ended questions. Yeah.
reiterated the last question, please?
Okay. So my last question is, how do you migrate the workflow that I just mentioned to you to apply to the workflow management tool all the way to the model publishing? So what will you do if you need to create a new workflow just for this?
You mean how to apply to the offline
the
process
concept to here
to what we discussed before?
Yes.
You see, the model training can be viewed as the task 1, and the model evaluation is definitely can be only done after the model has been trained. Otherwise, you won't have the model to be evaluated. So you put your model training part into the task 1, and the virtualization environment is the part 1. And with the same idea, you can put your model evaluation into part 2, and model publishing into the part 3. And also you want a high availability, so you can have many more than one replica for each of the pod. But more replica means to consume maybe more resources, not necessarily more resources. Yes, So you have to decide which part of the your offline process is the most important because the resource is limited. So maybe if you focus on more model evaluation, then you can assign more resource into it. And also you need to assign static IP for each of the part in your virtualization point, because the part 1 and part 2 need to send the data via either the WebSocket tunnel or the gRPC, and they have to communicate via the IP address, and the same is true for the part 2 and the part 3. So this basically sums up how I will model that flight in offline progress into our discussion before.
Okay, cool. Yeah, I think that's end of our today's mock interview.
Okay, thank you.
Thank you for your today. OK， 好，结束。哎，你讲的超好的耶，好强哦，好赞哦，真是很赞哎。
我觉得自我介绍比较难，我自我介绍真的不太会讲哎，就是因为我也没讲过很多自我介绍，可能就
最目前听起来，我觉得这个自我介绍是我感觉最不像是你会讲的东西，太不可思议了，不太像是你会讲的，我觉得。
我觉得我刚开始有点讲偏了，我突然变得有点想要介绍产品，但我又我觉得不太是要讲要介绍产品。
我大概跟你讲到就是你有什么地方没有讲好，但我觉得先不讲是身体上，我觉得其实你在那边，老实说我也不知道在出什么，所以我就拿我最近在处理的东西，大概跟你稍微谈一下。
好啊。
然后我觉得没有，我已经讲完了，就是你刚刚讲那些东西，基本上是我最近在做，只是我在做的是 serialize 跟 deserialize 的部分。那我觉得我觉得那个地方就不用讨论，因为就是有点太细节。但我觉得最主要的就是你在我问像比如说这个 task 有没有活着的时候，或是干嘛，你提出了很多不同的错误来源，跟你可以怎么去解决，我觉得这就很好。然后再来就是说，比方说就是怎么去 communicate。其实我这边只是想要去回答 gRPC， 但是我觉得你甚至把它怎么做连线什么，我觉得都讲错。我觉得其实针对这点，我觉得其实真的讲的蛮好，老实说。所以我觉得你在system design其实我觉得没什么问题。我觉得你最多的问题比较像是在前面这边，因为其实你整体下来，其实你不管是你不管是整个介绍或者是什么都好，我觉得你都讲得很清楚。但这也是一个缺点，就是你讲得太清楚了，就是你比方说你刚刚在讲自我介绍的时候，其实你讲超过3分钟。
对啊，
或者是我觉得甚至可能到5分钟。
我也觉得我讲太久，好像应该可以更 briefing 一点，对。
因为其实我到后面有点快不知道你在讲什么了。
对，我好像
我
很容易犯这个毛病，对，感谢你提醒，我自己蛮容易犯这个毛病的。
因为你讲的其实，超级清楚，就是你从你的 project 在做什么，然后从几月几号到什么时候开始讲。
太深了，
但是
太深了。
对，太深了，因为其实这样你会导致说，我后面其实原本想要问你说，你 SGT 跟 SOIT 这两边各自在做什么，其实我会没有时间去问这个，因为其实你大部分，比方说你要讲你的自我介绍的时候，我的讲法可能就会是，看一下你这是哪里啊？我是胡安凤，然后我在群晖有2年的工作经验。那因为我有什么，我可能第一个 team 是专门在做可能是 hybrid cloud 的 sharing 的 solution， 然后我其中做一个很有趣的 project 是
讲第一行就好了。
对，你可能就说我是 hybrid share， 然后什么 hybrid solutions to do this，and one of the project is你做个像什么 Word 那件事情，然后你可以就简介一下说那个 Word 的 I know 的 issue，so I resolve it with。
甚至不用简介，就说我做了 hybrid share hybrid cloud solution， 那我开发了一个档案分享，
对，
这样就好了。
对，你说hybrid cloud solutions related to the I know the issues and due to the I know all this bad design, so I use a string comparisons to 什么这样之类的。And now as for the recent project, I mainly just done the
对
file protocol load balance，然后这里面你去怎么 distribute the file I/O， to different node under 什么 cluster 什么这样子。
对。
然后别人就是大概你可能讲完这些，然后你就可以去讲说怎样之类的。就是可能讲完这些，我觉得其实别人就有很多问题可以问你了。
对啦，有时候会太，我的缺点就是我太兴奋，有时候就一股脑的讲进去。
我觉得你超级兴奋，你太兴奋了今天。对，然后对，然后其实我觉得还有一个同时原因是我前东西，还是这个，对，你在讲这些的时候，我觉得其实你的 technical 的东西都讲得非常的solid，我觉得非常的好，这是好事。然后你刚刚的问题就是就是这个，就是你有点讲比较仔细一点的，就是你可能在讲 RJ445，我发现是这个。
我觉得这个 VR 我讲不好，因为其实是这个 VR 的我年代比较久远的，然后那个时候其实比较。
但老实说，我的想法跟你保持相反。我觉得这是你讲的最好的一个。
真的，我就卡到不行，因为我觉得会有点在胡乱，因为我有点记不太清楚技术细节，所以就变得在那边胡乱。
没关系，虽然我知道你大概是在胡乱，可是我觉得你有把我想问的问题讲出来。就是你重点是你有我刚刚可能问你几个问题，然后你可能就一个一个问，把问题讲出来说所以你的第一个问题是你user 怎么去 participate， 然后你再回答。第二个问题是什么再回答。就我觉得这样子的回答方式是非常好。
字大一点，你那个放
Sorry，
都选放大一下。
Sorry，
这样可以，这样可以，好。
对，就主要我反正在 share 给你，然后
反正会有。
对，反正这些我都会给你。然后我有录影，所以我应该是有录到吧？
我也有录，不用担心。我从第1分钟开始录了。
好 ，OK。所以这些东西就是你可以再来看一下。
好。
然后我觉得你在讲这个 CPU OS，因为我今天会挑这些东西问，有个原因是我不太确定你要面的是哪一家。所以不管你是什么 Netscope， 还是你想要周面5本或什么之类的 ，Netscope 我觉得它在这个里面，尤其是你自己讲到你用什么 socket 去写什么，我觉得这很符合他们想要的东西。不管你是 Synology 或者这个，我觉得如果你真的有跟 socket 相关的，你真的可以稍微
我是下礼拜要面的，下礼拜要面。
那个你可能要准备一下，就是说他们在讲 socket 这件事情，可能要描述的简单一点点。我讲简单一点是说，从 user case 去带，这个我会在 SGT 那边稍微讲多一点点有关于这件事情。但我觉得你在 CPU 这个，我觉得你讲的真的超好，就是你很清楚去讲说，就是你为什么要做 multi-thread， 那你之后你又是做一个什么 optimization， 我觉得这个就是别人还没有问，你自己先讲完了，我觉得真的很好，就是我真的没话说。
缺点，我已经想听缺点也蛮重要的。
缺点。就是你有时候你应该要来问一下，我觉得我是写在这里。我觉得你要问。
我觉得这个是那个我远距面试的时候很容易讲，尤其是这种分享类型的，因为你看不到对方的表情，所以你就想要一直讲。
你可能需要先问说
，Is OK 什么之类的。
Is there any problem so far？
对。
就是你可能，比方说你讲 VR 或者是讲 CPU 的时候，你可能就是说，这个东西最主要是什么，然后我 accelerate 这个，然后在之后，对，然后因为你在讲这个东西的时候，我觉得它的重点是在detail之前，就是在讲detail之前，你应该先问说 ，Is there any problem so far？ 就是不然他可能大方向都不懂，然后你就直接开始讲detail，
对，
他根本不可能听得懂。
对，那感觉是我真的会犯通，就是我之前要口试的时候也会这样，就是硕论口试的时候也会这样，只有也有被老师刁一下，他有跟我。
可我觉得这也不是刁，我觉得就是你可能不太知道这个要怎么做。
对，尤其是
我觉得可能是
隔着
不习惯的问题。
我觉得是没有开视讯镜头又隔着的关系，就很容易看不到对方的表情，然后你就会好像以为是单一个人在讲话，你就一直讲。对，这可能真的。就是自己的时候真的要特别注意，不是自己就是隔着视讯。
但这里的时候，我觉得可能要稍微注意一下，我觉得。
好，
我觉得，然后我想一下再来，我觉得基本上这边就其实没有什么太大的问题，就最主要是让你去讲这个。 然后 summary open 还没有写 summary，我再写一下。然后说 SGT 这边，我觉得你有个最大的缺点是，你在讲这，你会直接讲说你有一个 I know 的问题。那一般来说，大概应该说，大部分人都会预期会知道 I know 是什么东西，跟它代表意义是什么。可是别人一定会听不懂的地方是，为什么会忽然讲到这个？
对，应该要先讲说我们要做档案 sharing， 然后是用 I know 去记录。
对，就是你好像讲说，我觉得档案 sharing 可能还太简单了，因为档案 sharing 其实跟你做的 I know 其实是两码子事。因为你档案其实不是档案，是档案协作，
档案协作啊，对，档案协作，
对，重点是协作
，collaborate， 对，
对，然后你可能要讲出的状况是说，比方说，如果是协作的话，你应该说，就是
协作会造成，
因为你是你是在多台，我发现是不是多台哪，甚至我连这个都不知道。
对，你就是协作的时候会造成存取失效啊。
对，你在多台机器共用同一份，就是可能文件的时候，你遇到的问题。
对啊，我讲的有点太文绉绉了，太绕了。
对，所以你在主要是这个情况，你要讲完之后，别人才会知道哦，原来是这个问题。OK， 所以你会怎么去处理或者什么，那就很 make sense。我觉得这个是你可能需要先去稍微注意一点的地方。
好，
然后最后的话，我觉得没有太多问题。我觉得，因为其实就是
差不多的问题啦。对，
我觉得你的问题其实就只有两个。第一个是别人不知道，big picture 是什么。
对。
第二个是
很容易就自己讲起来，然后不等别人那样子。
对，我直接做 summary 好了，这样顺便你也可以一起看。就小 SUMARY， 然后主要其实你的
但我觉得英文讲话口音很重好惨啊！
你要
对啊，
我觉得那不重要。
那应该是因为华人的关系吧，华人好像都有个口音。
我觉得口音什么那根本就不是问题，重点是内容。你的东西都很有内容，所以其实
可是
根本没有关系。
我都用小学生英文，就我没有讲一些很酷炫的 buzzword， 还是没差。
不重要，因为重点是沟通啊。你跟我之间的沟通没有任何的问题，不是吗？
那就没差，对 ，OK。
对啊，重点是没有那个。
对啊，沟通比较重要，不要偏文就好。
对啊，对啊，你要讲一些很奇怪的东西，
然后结果对方听不懂没有用。
对啊，对方听不懂没有用，就是你讲的就算再酷，听不懂没有用。其实最主要就是3个点啊。第一个就是你有时候讲的太 detail 了，就是
跟我
真的太 detail，我真的听不懂。我真的蛮抱歉，我真的不是故意的，可是我真的听不懂。
对，我觉得这是我的问题，对，因为就是突然脱离一个很跟工作的人讨论的，就会。
这没办法，我觉得这是
就是心机要转换。
我只跟你说有这个问题，然后再来就是你可能在讲问题的时候，讲问题要被 picture。
对啊，要先有一个大纲。对，
然后最后的话就是随时让别人问一下问题，他会 keep up。
对，第3个最容易忘，因为是隔着电脑、隔着视讯就容易这样。
没错，基本上是这样。好，把这个交给你。
好，谢谢你。
没事，我觉得你整体来说表现的真的是猛，所以没什么好担心的。
看起来在巡回真的会学到一点System Design的知识
会啊，就是我觉得你是有带到那个有办法让你去摸System Design的地方，所以我觉得是好事。
对，
就是你做的事情是比较大一点。你基本上我问你的问题，虽然你都没有做过，但是我觉得你可以很快的去找出它可能是潜在的实作方式是什么。我觉得这就不是一件很容易的事情了，坦白说。
好，那非常感谢你。
小事你都帮我这么多，你都帮我去拿你的头去打你老板的脸了，所以总之我们还好吧？
不过没办法，还是就不是没办法，就是好像真的没办法，这个时候面试你。
对啊，我的意思不是说面不面试的问题，就我今天在意的事情是你去帮我做这件事情，就没有面试，我觉得这件事情本来就是看缘分。
哦，对啊，因为
那天
真的聊了很久，我跟全玉聊了半个小时，又跟白毅聊了快1个小时。
对啊，我觉得这些都是你帮我去做，我其实很看在心里啊，就很感谢你愿意帮我做这件事情。今天不管，我觉得甚至就最后什么都没有，我觉得其实我是预期什么都没有，只是就是我甚至不觉得你应该要帮我这么做，但是你还是帮我这么做，所以就很感谢你，讲实话。
好，
对吧？
也很感谢你帮我 mark，这样是讲英文也不错。
对啊。想我把影片丢上来，那是我自己版本的，我不知道是不是可以这样直接开，但应该是可以吧？
你是用什么？OBS 吗？
啊，我用 OBS。
你说你用 OBS？
对，我用 OBS。
我也是用 OBS，那就可以了。
怎么分享？不会耶，不是按这个吗？这个吗？
哦，他先换地方。
哦，这个。对啊，先换一个奇怪的地方。给你download。
好，我自己也有录，不用担心，都可以。
哦，是当做 replica。
好，可以。
OK， 好。还有啥其他问题吗？
没有，很感谢你今天一起模拟面试。
觉得这是一定要的。
对，因为下礼拜2是 Netscope 的 Final Round。
Final Round 这么快啊？你练几次了？
它跟 Google 一样啊，先1+3嘛，先1再3呢，所以3那个。
他已经过3个了。
我没有，我先过1个啦，就一样 OA 嘛，有点类似 OA 的东西。
哦，好。
不过它考的比较特别就是了啦。